Hello, hello. Can you hear me?
Yes.
Okay, good. Because my microphone sometimes break. Okay. So good morning, to all. Thank you very much for writing that email. Yeah.
You are
Actually, carefully, but yeah. So nobody's here. I guess everybody's busy with software project. Okay, I messaged Boo and Brown. Let's see. Since they're not here yet, let's check the email. Just quickly read the email. It seems Boone was in the middle of meeting. Oh, you wrote back on my forum post. Nice. And I think Brown is going to come soon, I guess. So okay, so Tor, when you say that bouncy castle and open source SS does allow for parsing yet not validation, I think I just want to, like, speaking of terminology, parsing to me. So when you say allocating, for example, allocating the data into the corresponding elements. For example, finding out which field is about subject. You call it validation, not passing, right?
Yes. So the way I see it, there's like two things. I would say that that validation means that you take whatever BER encoded data you have, and then you make a data structure from that. Whereas validation verifies it against a pre-specified data structure.
Okay, so your validation returns a structure instead of Boolean, yes or no?
No, I would say like if you validate it, it says like this encoding. If you give it an encoding and a module, it says this encoding fits this module. Whereas parsing means it takes like the pure binary data, and it follows the ASN1 rules to extract the information within it.
Well, in that case, if I can write a Python module, then it can directly parse and validate ASN1 data.
Yes.
So what is the point of TokenScript engine first parsing data from OpenSSL?
So the way I see it is, I mean, like in that case, okay, yeah, you can just, as you suggest, you can do everything server side. You send the ASN1 module and you send the encoding to the server. The server validates and passes this into a JSON, which you send back. back to the app, and then the app passes the JSON into whatever object structure there is. And so what I said was that instead of that, you just directly optimistically pass whatever encoding you get using OpenSSL or Bounty Castle, while at the same time sending, like in parallel, a request to the server to actually to validate that it fits the schema it's supposed to, so to fit the module that it's supposed to fit. Because otherwise, I think it's gonna take quite a long time if you first have to send it to the server, then you have to wait for the server to compile it, to pass it, to validate it, and convert it into JSON and send it back, and then the app has to pass the JSON into an object structure and then do its thing. It might not be that much of a difference, but yeah.
Okay, so now I understand it. Okay, thank you very much. Yeah, makes sense.
Is it also is it essential? What happens if it isn't validated? If the structure we get is different than the schema described? I'm just wondering if we can be optimistic, because if we're allowed to be optimistic, then we can cut out this whole server compiling part of the equation.
Yes, I think whatever we do on the server is only bridging, because we don't want someone to listen to the network and know the user is probably how many data packages the user sent to the server for passing. So I think the server simply is a bridging solution until we find a way to do it, for example, in JavaScript. And the reason being that I already know how to make it in Python. If I make it in JavaScript, it might take longer, but it will still be possible, I guess. And then we have the problem how to retrofit the JavaScript into iOS and Android. Yeah. Okay. So so Bo and Brown, are you guys here? Can I start from this beginning?
Yes.
Yes.
Okay. So I'm going to share my screen. I just took a photo of my drawing.
Can I just ask one more question about this, Bebu?
Yeah.
What exactly will happen? Like, which bad things will happen if it's not, if the module is not, if it's not if the ASN1 encoding is not validated against the module, and we simply assume it is it's correct. Like, I mean, it will show up, I guess, at some point, at some time. But the question is, will that be allowed? Will it be an error we can handle at that time? Or is it essential to actually validate that it fits a predefined module structure at this point?
I really actually don't understand your question.
Okay. My question is, I mean, it's possible to simply pass whatever BRD encoding there is on using OpenSSL or Bounty Castle. But what we don't know is whether this passing fits a pre-specified module. So like
you don't find the values for specific fields.
I mean, you get the values, but you don't know if the structure of the module is the same as in as has been specified in the ASN1 module.
Yeah. For example, if you get a certificate, then tell me what is the public key. You can't tell me.
So yeah, you mean when you have a like a customly defined TokenScript that, for example, uses some other field name for the public key or something like that, but then has to.
Yes, I think so. Just for example, or maybe like somebody produced a attestation for the UEFA ticket, and the goal is to get the ticket number, and you cannot get it even if you can pass the ASN.1. If you can pass the DR encoding.
Yeah, I see.
Yeah, so it's pointless to be able to get
and this is it's at this point you will need to extract this. I see. I see. So like, as far as I could see, like the way it was done in like Bounty, I think it was Bounty Castle or something like that, is you can extract like the third or the fourth or whatever element of. No, I think. Yeah. Okay. I see what you're saying. Yeah. I mean, you had the freedom of basically saying, if you already knew what the structure. If you knew like the ticket number is the fourth element in the structure, but that needs to come in. Yeah. I see the problem. I see what you're saying. I see what you're saying.
Yeah. Okay. Yeah. Okay. All right. So let's get one level above and look at how the process goes. I just wrote a page on Note. You guys can see my screen, right? Which is sketch.png.
Yes.
Okay.
Yes.
So two things that we probably already discussed, but let me rephrase it or recap it. First is that if someone invented a new token that uses attestation or is attestation, like somebody invented a UEFA ticket, he only needs to define the data object for the ticket in the TokenScript, and we have an implicit rule of how the attestation on the ticket should be. So if you have a defined data object, then automatically a attestation is defined for you. You know the data structure for attestation, and the attestation signing request is also defined, which is not useful in the FIFA ticket, but is useful in the email identifier attestation. So the point being that the author only needs to define a data object, and we complete the rest. That's the first point. The second point is that if the website requires certain message to be signed, the website should launch a card. And on the mobile phone, that means the user is going to be taken from the dev browser to the wallet section. Actually, it doesn't have to be wallet section, it's just to somewhere that is not a dev browser to finish the action. And once the action is accomplished, the user is taken back to the website. So this is the way a card can be used on the website. That's one example where the website can launch a action. The other example would be the website can request a proof, which will also result a card being launched. And the user select if they want to provide the proof and how. So that's the two use cases of cards. And I think I discussed this before, right? Did I? Like how cards can be used for the web.
Very briefly.
Yeah.
Can you summarize quickly what are the two examples? Because I think I only caught one.
Okay, one example is that website wants you to do a transaction or sign something. For example, donate $3 to me. Then you click the button, then the action pops up, replacing the web page. That action has the address already filled in, and just have to yes, I want to give $3 to this guy. And then it comes back to the website. Basically, a website launches an action in order to get a signed message or a transaction.
Okay.
So the action is signed by the website as an attestation, right? Okay.
The website, the action is the code in action is signed by the token issuer. So let's say if the website say donate 3 DAI and click yes, and then you get an action to donate 3 DAIs. That action is written by the DAI people, not by the website.
Sure.
Ask you to donate $3, and the card opens. The code in the card is signed by the DAI project, and the result is a transaction or a signed message. Both of them signed by the user.
Wait, why would the DAI need to be signed by the DAI people? Because isn't the fact that it's already on blockchain mean something that it's no one's questioning that it's actually DAI?
Oh,
but they might be questioning that the action is from the website.
You mean why does the DAI project signs a card, not the code for the card, not the website signs the code for the card?
That's right. Yes. Yes.
Yeah, that's because of the trust boundary. So the idea is, if you spend 3 DAIs, you probably would allow some JavaScript to produce signed message or transaction on your behalf, if that JavaScript is also coming from the DAI people. If it comes from Wikipedia, you might be concerned that the Wikipedia might ask you, do you want to donate 3 DAI? And when you click yes, it actually signs a message of all of your DAIs, which is 3 million DAIs, and pass them all to Ether. Actually, not only that, the same message also send all the Ether to them.
Okay.
Does it make sense? Does it make sense?
Kind of. I'd rather that the website signed the request rather than the DAI people, because I can just yeah.
Okay.
But anyway,
that's actually
I
very
suppose.
important.
Yes.
So we probably can linger on it for a little bit more. So let's say you have a car token, let's say Karma car token, which represents your ownership. And then you can authorize usage of that car. And then you have an action called authorize usage, which sends a transaction that allocates usage to a different address. Make sense so far?
Yes.
Okay, let's say you run a website called Car Next Door, where you can rent your camera cars.
Oh yeah. Okay. I see. In that instance, I see where you're coming from. Yeah. Okay.
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 Sorry.
All right.
Okay, then coming back to the donation website. Suppose it's not Wikipedia. This is just to imagine. Suppose it's not Wikipedia, but instead you receive a letter called donation to the animal welfare. And then maybe that's email, and click that link in the email, and it shows a lovely story of how a dog was rescued, and then ask you to donate $3. Then 3 DAIs. Then the thing is, when it pops up an action, you want to be sure that when you finish the action, you let go of 3 DAIs. But you probably cannot trust the dog welfare website to be as trustworthy as the project that is the stewardship of your token.
So what is the mechanism by which I get the DAI people to sign my my transaction?
No, the DAI people don't sign your transaction. The DAI
Sorry, not the no. All right, okay. The transaction request, I mean.
Oh, the transaction request is actually not by DAI people. The code to produce the transaction, which is
Okay. No. You misunderstood. I mean, what is the mechanism by which the DAI people will sign the code that I write as the transaction request?
In which they define the transfer function, transfer card.
Okay. But presumably this is something that we have to ask the DAI people to set up, because it's not something that exists at the moment.
No, but if we want to tokenize things, such usage will be more common. Let's give you an example of Buttercard, right? So Buttercard, let's say, has a thing that says that if you spend $1,000 in an entire month, you will be given a golden medal, which allows you some privileges. This is indeed this is so that the entities who are usually recently rewarded of the newly minted Butter coin will not keep the money in the wallet, but spend them. Let's say Buttercard has this purpose. They want you to spend the money in a month. A little bit like how the US government wants the epidemic fund to be spent by the user, by the recipients, not instead of being kept in the wallet. Otherwise, it wouldn't move the economy. Buttercard wants to move their economy too, so they have this reward thing. And at the end of the month, you receive a notification saying that you have spent $900.50, and you only need to spend $50 in order to get the golden medal, which will be equivalent to a holiday in Perth. And this last day, so you want to spend $50. So just go to some places like diaper delivery or cocoa coffee. You just go to a website, and then you want to spend that $50. Now, remember that this is the case where Buttercard has the intention what to do with the token. So they might pop up a card and ask you to put $50 there. And then it will play some music, give you the golden medal right on the spot, so that you know once this transaction is finalized, you will get the golden medal. That will be some code that they want to put into TokenScript, because in this case, the transfer function look different.
I'm just concerned that this mechanism might introduce some extra friction. That's all. Because the problem is you presumably you're going to have to vet each one of these transfer requests. Either some kind of process, a website, will automatically vet small scale ones, but I'm just concerned that this is introducing some development friction here, unless it's handled very well.
Development friction for whom?
So let's say I'm a coffee site, and I'm basically making a sort of a thing so that you can buy a coffee for 3 DAI, and I have that request, but now I realize, oh, I've got to get it signed by the DAI people. So let's say I have an event happening tomorrow. So the DAI people, I have to be sure that the DAI people are going to see my request and sign it for the event that I have tomorrow. Otherwise, it's going to be an unsigned request.
That certainly won't work. Anyone who designed that
yes.
is doing.
Yes.
So it's not really like that. So DAI people only sign an action called transfer or pay. That's the action. Whether or not it's a coffee shop, cocoa coffee, or diaper delivery, they just need to use the action called pay.
Okay. So basically, it's a variable. You have a variable amount going into this attestation.
Can I word it in a different way? And Wei-Wu can correct me if I'm wrong. I think you're saying that the DAI people, they only sign a TokenScript file which describes their own smart contract, not the coffee shops. I think that's what James is asking. He's saying that they shouldn't be made to sign a TokenScript file that is based on the coffee shops smart contract.
Coffee shop has no TokenScript file.
Sorry?
Okay, so basically they're signing the DAI people's attestation. But yeah, okay, I don't really. Okay.
The DAI people only have to sign their own smart contract.
Yes, I understand that. Yes, yeah. And then when I go to use this, then I will be like, is it like Legos? So basically, I'm plugging in the DAI people's attestation in my transfer request, so that I know that
transfer request, something like that.
Yes. So basically, I have so each coffee is 3 DAI, and I have plugged in the DAI Foundation's transfer TokenScript request, so that the person who is signing can see that it's from the lower level transaction request is from DAI people, so I know it's only transferring DAI.
Yes.
Yeah. Okay. Yeah. All right. Okay. Yeah. I see how that works now.
So far, whatever you said is correct. Did you finish? Boon?
Yes.
Whatever you said so far is correct. Did you finish?
Yes.
Okay, you finished. Okay, all right. So we just recapped what is a card and how is it supposed to be used on the web. as well as the second story where the card can be used on the web is the web requests certain proof, and the card is able to generate that. For example, you want to generate zero knowledge proof or some kind of anonymous proof that you are not a citizen of you are not U.S. citizen. Then maybe what you do is you have your identity attestation, and then you provide some proof, and or maybe you go to a website that's check your age, checks your age before offer you to alcohol for sale. Then you want to prove the age without revealing other stuff. So that's the other way that the card might open. So in this case, it's not open to create signed message, but open to create proof of some sort.
Okay.
Yeah. Okay. Now coming back, that's the card recapped, and the attestation requires TokenScript author to define the data object. That's clear to everybody, right? And only the data object, but not the entire attestation.
Yes.
Okay. So let's talk about the story. We have the protocol Alice sent Ether to Bob by attestation. So right now, what you are looking at only focus on the part of the story where Bob gets his identity attestation, identifier attestation, which attests to his ownership of the email address or SMS mobile phone number. Yeah, this is. So step number one, I cannot, you cannot see my mouse, but look at the first square.
We can see it.
You can see it? Okay, so
yes.
I'm around this square. This is the first square. This is the place where the user visits the website, and that website has the TokenScript for email SMS identifier and identifier TokenScript. So in the beginning, we might not do this. We might simply put all the TokenScript in the repo. So it's equivalent to having TokenScript in the repo. If you feel this is troubling. Okay. Then when the user opens this website, the website would have a few fields few data fields and a OK button. Clicking that OK button runs the request sign request action card. This allows users to sign attestation signing request. And then user hits send back, and then this request is sent back to the website. This website is the tester's website, by the way. So now the website acquired something signed by the user. The website next step, it do the stupid thing that asking you which one of the 4 pictures has a bus in it. Not 4. Which one of the 9 pictures has a bus in it, or which one of 9 pictures have an airplane in it. And then it will ask you, a user, to type the verification code sent to the mobile phone or the email address. Now, if you pass the code, the email verification code and SMS code test, then the website is able to offer you the attestation for download, which is a big download button. And if you hit that button, you get a new attestation, which is like a token to you. Then you can save that attestation to a mobile wallet. Of course, this attestation has a preview. You know, James Brown, you made a TokenScript viewer, something like this, so the user can see what is in the attestation before downloading it. So here, the process of getting the attestation from the tester's website is done. Now, let's suppose the user is asking Alpha Wallet question on Alpha Wallet website. And that one requires the user to have verified email address. So the website displays a field, say, what is your email address, verified. And instead of typing an email address here, you can hit a button to get your email address attested. So what you do is you hit a button, and then the mobile phone will pop up the attestation about your email address, and you select that and select send, and that attestation is sent to the website. At the background, there are some challenge response, authentication, but you get the idea, and the website will believe you have this email address without asking you to verify your code again. This is the whole process where attestation can be used, not touching the blockchain at all, and not touching Alice transferring money to Bob, because we want to have a smaller project out of the Alice sending Ether to Bob project. That's what I have in mind as a smaller project to do, implementing what TokenScript already have without touching the blockchain, and by using the card and by using attestation and by using download attestation. Make sense so far?
Yes.
Okay. Can we already move on to the detail? For this high-level view, do you want to talk about it?
Yes, let's move to the detail.
Okay. Let me share a different screen. Okay, so these are the data structures that we were going to use. Most of them are copied over from X509. So let's go to the first one, the attestation framework. So this is the XML definition for that. ASN.X module. It's a little bit long and less readable, so I will open the equivalent translated into traditional ASN1 and discuss on that. So what it has is attestation of a data object has the following: that it has signed info and signature. These two together is the signature. Then in the signed info, it has a bit of versioning and the issue year name, the validity, expiry date, the subject of the attestation, which contract is relevant to, and this part is the part where it is customized by TokenScript. That is what is being attested to. And in our case, we always attest to a data object. Extensions is something that in the case where if someone wants to reuse his existing X509 in our framework, then it's the extension. Otherwise, it's data object. So yeah, so this is the structure of signed info, and then we have subject public key, which is used here because it's included in the signed info. Actually, we discussed this before back in November, but this is a recap and some small corrections. So far, so good?
Yes.
Yeah, this is automatically generated once the user provides the data object. And then this is the authentication framework, which contains the bits of data structure that is used. And actual data structure, the more readable SN.1 format here has the algorithm identifier, version number, serial number, all the fields previously used are defined here. This is like a utility class with all the random stuff are defined here. And the most important thing is only the name. Where's the name? And anything else is not so important. Name is not defined here. Did I make a mistake? Where's name defined? Anyway, if name is not here, then this file is not really important. It will simply be, I guess Boone and Brown doesn't even have to touch this file because it's going to be plugged into the ASNX compatible library that runs in the, probably in the Lambda in the beginning, and later be ported into Android and or iOS. But currently might be in Lambda, meaning that every time when you need to, the mobile wallet needs to understand or write, understand some, not write, understand some attestation. You send the attestation to a Lambda server running on the server and get the JSON back, which will already contain the information of the data object as well as if the attestation is valid, and leaving out all the attestation fields. Yeah, that is not relevant. The information framework is probably where name is defined. Yeah, this is the only thing that is important. So name is the name of the attestation, and it's used. It's basically a key value structure, a key value sequence of the key of the primary keys of that that object. We have had this before. For example, if it's a vehicle, then the name of that vehicle might be vim equals to followed by the vim number, which will be a sequence of key value vim and number vim, which is vehicle identification number. And in this case, there's only one pair of key value. Yeah. And then my attestation is that example. We made this example in December, last November, because at that time we were under the impression that we are going to prioritize FIFA ticket as a attestation. Again, I show you the ASN.1 .1 module, which is easier to read here. Okay, so this is a ticket, which is a data object. Sorry, this is a typo here. I should not say data object here. Anyway, this is a data object defined as a sequence of the ticket number, class, and date. This is the same thing we used to discuss attestation in November. Now I should create another one for the email identifier. Yeah, so this is going down one level for the data structure. I didn't have the file for the signing request, which I simply hadn't been able to produce before this meeting. But having that, we should have had all the data structures available. Then the next thing we need to do is just to plug a library to it. I think I just finished explaining what I propose to do in this project. And we have 7 minutes left.
Is there a project we can test this against?
You mean all these data structures? We want to do this with the identifier attestation, which is the email or SMS.
Yes, but are we also going to prepare a website which uses it?
The tester's website, yes. It is going to have the. It is going to offer, verify SMS number, or verify email verification code, and display 9 photos of buses.
Okay.
So you mean, do you want to list the components we need for this? So what we need
No, I think you answered my question. There will be this website with the 9 photos and stuff.
We have 3 components: the website, the AWS Lambda, which is used to get a attestation and return JSON, corresponding JSON. The intention is to put the Lambda later into the app, but it's not. We're not in a hurry to do that until later this year.
Okay.
And some code has to be done on the Alpha Wallet side so that card can be started from the web and then return the signed message to the web.
Do we need to think about if it's possible to write an EIP on this?
Yes, I just don't know how to write one without without actually involving blockchain. But we can do this together with next thing when Alice and to Bob case is done. Then it's touching the blockchain finally.
But one problem with this is tied to TokenScript. Is there a way to make it somehow work without TokenScript? If we want to write an EIP on it.
It already works without TokenScript. So you know that one example is called I forgot which website. So back in the 90s, there is a wave of several websites which, being frustrated that user leak their password from time to time, started to also offer user certificates instead of username passwords. So if you go to such website, instead of a username password login box, you only have one single button called login. And if you click that button, you can choose a certificate to log in website with. We are compatible kind of with that technology because the attestation we generate is based on X509, just like their certificates. Let me find a picture of that. Is what I'm doing in line with what you are interested in?
Yes, but I mean, in order to define the data object, you have to write a TokenScript file.
Yeah. Which
brings in a lot of components which, if someone is reading the EIP, they will not be interested in.
I'm sure if we write an EIP, we should leave out all of the attestation framework, authentication framework, information framework. We just give them the core example. Here it is. Because EIP is not RFC, it's supposed to be read in 5 minutes.
Okay.
Okay. Sorry. Let me see. I used to have a screenshot to show how it used to work before TokenScript. Because before TokenScript, it was RFC. The reason being, at that time, people believed that there's only a few certificates. Mostly they are certifying the user's identity. So if you can define, it's a finite number of things you want to certify. Therefore, they define them, fix them into RFC. So the website simply knows, without somebody writing TokenScript, the website simply knows what kind of signed data object they are going to get. They have a pretty good idea of that. And the user, when they are offered to store their certificate into their browser, the browser knows what the certificate should be like. That was the good old 90s. It was proven to be a failure because people love to use passwords. But at that time, there was no such concept called a wallet security device. Now we do have that. So maybe we can revive that. But today is different than previous times. Today, we need to make tokens work. Previously, it was just certifying the user's identity. So now we need to customize it for data objects. For example, if the user has a FIFA ticket, then he's able to access some functionalities on the website that is not available if you don't have a FIFA ticket. That is no longer the traditional certificate that is hard-coded in RFC. And it's token. So that's why we go one level more complicated by allowing TokenScript to customize that object.
Okay.
Yeah, and the ways we store that object is the same as they did back in the 90s. Except that now we have a customized schema. Yeah, okay. So I guess it's 7:15 already. Anyone can leave. If you still have questions, I'm happy to stay online, coffee, and answer questions.
I was wondering one more thing about the ASN1 stuff, because basically, if it's so a lot of the this information about variable names and things like that. I mean, in general, if it's BR, DR, PR encoded, we don't have that. but it's part of the specification of, say, JER or XER encodings. That is like the JSON encoding or the XML encoding of an ASN1 that actually includes these variable names. So I would imagine, like, if we can we simply state that it must be encoded in this format, or will what we get always be encoded in BER and DER?
Yeah, so the fact that these attestations are intended to be compatible with the blockchain means that we cannot do JSON. Then it will cost too much gas.
Okay.
So, yeah. So although for this purpose, which is the one page of note I shared before, we can use any encoding. But soon we will enter the second project where it goes to the blockchain. So better only BER, I guess.
Okay.
Yeah, I think so. Yeah.
Okay. But I guess then, yeah, as you also mentioned, the best solution is probably to have a lambda, and then I guess because I think like this thing called ASN1 tools allows it's a you know, the Python thing basically allows to switch encoding formats such that like you can give it a BER encoding and an ASN1 and then it returns it in JER or something like that.
I only know that it reads BER, DER, a few CER stuff, but I don't know if it's JSON. But I think it's common sense. If they don't return JSON, everybody will be very angry because JSON is a standard data format today.
Yeah.
So I think the library must be able to return JSON. I haven't checked.
What was the name of the one you were looking at?
Oh, so it's called PYASN1.
Okay, because I looked at this one. And as far as I can see from the example, it basically allows you to give it an ASN1 file and an encoding, and then you can use this to convert to like a JER encoding.
Oh, this one doesn't even have it only supports BER, CER, DER. It didn't say JSON. Oh, nowadays these things are really not millennials compatible. So what is your ones?
I just sent the link in the chat.
I need to find where is that chat box. The user interface is amazing. Chat, yes. Oh, this guy supports huge number of stuff.
Yeah.
And does it support? I need to see the stuff like actually define optional type. It's not about encoding; it's about the schema thing. So I need to.
So he writes this known limitations. Oh, in the top of the.
Being able to handle a default or an optional would be great. Because otherwise we have to do it ourselves anyway.
Which one did you say?
So I want this. This is something if they don't provide, we will have to do.
Yeah. Okay, so I haven't played with it just found it, but I didn't see it. He mentions like 5 different limitations, and it doesn't seem like I'm not sure if option is captured as a subset of one of these.
So the advantage is that this one has JSON support. So
yeah, so basically there's a single command that just takes an ASN1 specification and a BER encoding, and just returns a JER encoding, which is just plain JSON with the
it's here, right? Example here.
yeah.
So this is a module, and then it takes the module, and then it takes the file, and then it returns the JSON, right?
Yeah, there's an example on.
Sounds like what we need.
Yeah.
Do you know how to program Python?
Oh, I've only used it like to make small command line tools. I haven't actually done any proper coding, or just like since I never learned scripting, I always just made like a straight line Python program that just called everything in the command line, since that was the fastest.
Oh, okay. In that case, I will take it to myself to compare and evaluate these two libraries.
It seems like the first one you mentioned, as you said, doesn't support all the formats, but I guess then you could just use another library in Python to convert directly to like whatever internal representation, convert that into a JSON. But if but if this ASN1 tools work, then it seems super easy, because it's just like a one-liner that does everything we need.
Yeah. So the problem of PYSN1 is that we need to figure out a way to return JSON, and for the because otherwise it will be just object tree. And for the ASN.1 tools, we need to see if it if it's doing what we thought it's doing, and also that can take in what we generated. Yeah.
Yeah, I think the main issue is if it has some limitations.
Actually, this
but here there's an example.
It looks like.
If you look at the one a little bit further down, there's one where they basically literally takes a DER and the module, and basically returns exactly what we want in a JSON.
Nice. This looks really like what we need. I'll check this one. Would you reply the message quoting this, or edit your post?
Yeah, I'll edit the post.
Okay.
So the other, I sent you an email like about Vlad's comments about the sender. The sender being able to learn the secret in the future. I just, as I mentioned, I thought it was something we discussed, but we might not have. But anyway, my question is that basically that this can be handled with like very, very simple zero knowledge proof, that you know the exponent instead of actually leaking the exponent on the blockchain. But I'm a bit unsure about what handles we actually have efficiently in the Ethereum.
I actually don't know either.
Because it seems like what we're already doing is is to do an exponentiation, or like a point or multiplication, if we consider this something on an elliptic curve, and basically like this the zero knowledge proof is more or less the same. It's instead two exponentiations and one multiplication, and that's basically it. And then x is completely hidden.
That doesn't look complicated.
It's not. But I just got thinking, like with this, like exactly which handles we have to efficiently do. Because as far as I remember, it's something more standard. Like if you just do an ECDSA signature, I mean that you have like a handle for. But any kind of operations in the group of which ECDSA works or something like that, I'm not sure if that's
we might have to dive into the bytecode, but I'm concerned that the way Vitalik develops things is probably only providing signing, for example, and even the bytecode is probably just signing as a bytecode.
Yeah, that's also what I would imagine.
unless he does it really nicely with finesse. We will have to check.
But regardless, the problem would then be the same, regardless of whether we do a zero knowledge proof or not, since even our first solution, or previous attempt at the solution involves a multiplication, which is I mean, it's
oh yes,
still a bit
yes,
different.
Already used that. You're right.
Yeah.
Yeah, this is luckily we have time to research this, because Bob project go on. We don't need this. We only need this when it comes to Alice, I guess.
Yeah.
Actually, we need it in Bob too, because the attestation is there. Does it change the attestation Bob gets?
Like very. Oh, the attestation Bob gets. No, he just gets. He gets an attestation on his mail and this number. No, it just changes. It just changes what gets sent to the blockchain.
So it's
then instead of sending
key,
X,
isn't it?
no, instead of X, he sends 2 values and the attestation, and then it's just like a simple computation on this.
Well, I hope it doesn't. I hope we can draw a circle around Bob and finish that. In the meanwhile, we study what to do with Alice and Bob.
Yeah.
Okay, so and this is the circle around Bob.
Yeah.
Okay. Oh, good. Then we discuss in parallel. Deal with Bob and in parallel think about how to deal with Alice and Bob.
All right. Yeah.
All right. It's been an hour. Thank you for having fun with me. Yeah, James. You guys are happy with this? And then we call it off.
Yeah.
Okay. Well, have a nice evening then.
You too. Bye.
Thank you.
Yeah.
Bye.
Bye.
哎呀，为什么这儿湿漉漉的，宝贝？别掉下去啊！别掉下去。